All right, we've collected our data, and now we're going to graph it. You can use a bar graph or a scatter plot or any sort of graph like that, and you'll end up with something that looks like one of these graphs right up here. And we're have a normal distribution. We have a distribution that is positively skewed and a distribution that is negatively skewed. If our data is accurate, or if we're pretty much centered around the mean, and this would be the mean, then we have a normal distribution. If it's positively skewed, all right, then the mean has been shifted to the left, and it means that some of the positive numbers that we would expect are not there, so it's positively skewed. For negatively skewed, again, here's the mean, and the negative numbers, or the numbers in the negative direction that we would expect to be getting, are not there, so it is negatively skewed. Now let's take a little bit closer look at the normal distribution. And another name for this is, and you've probably heard me call it, a bell curve. Kind of looks like a bell. And again, here's our mean. And to be a normal distribution, the graph has to be maximized about the mean.
US 74 business and US 76
the mean, the median, and the mode also have to be about the same. If those are a lot big difference, then it's not completely normally distributed. And about 68% of the values are within one standard deviation of the mean. So 68% of the data falls in between these two lines right here. 95% of the values are within two standard deviations. So here's negative 2 standard deviations, here's positive 2, so 95% of the data falls in between these two lines right here, and 99% of the values are within 3 standard deviations. So 99% of the data falls between here and here, and that just about covers everything. And to break it down even further, if 68% of the data falls between here and here, then 34% falls between the mean and -1 standard deviation, and 34% falls between the mean and +1 standard deviation. 95% falls between here and here, and so if I subtract 68 from 95 and divide by 2, 27% divided by 2 would be 13.5%. So 13.5% of the data falls between +1 standard deviation and +2 standard deviations. 13.5% of the data will fall between -1 standard deviation and -2 standard deviations. And that means that if I take 99 and subtract from it 95 and divide by 2, that 2% of the data falls between 2 and 3 standard deviations, and 2 and 3 standard deviations on the negative side. And 99 minus subtracted from 100 divided by 2 is 0.5, so 0.5% of the data will fall above 3 standard deviations, and 0.5% of the data will fall below 3 standard deviations. We can also combine these, and we could, of course, then say that 47.5% of the data 47.5% of the data falls between the mean and 2 standard deviations. 49.5% of the data falls between the mean and 3 standard deviations. And you guessed it, 50% of the data is above the mean, and of course that means 50% of the data is below the mean. Now let's look at a real-world situation. And, depends on how you want to look at real-world situation. I have a set of data that I have found the mean to be 60 and the standard deviation to be 15. So if the mean is 60 and I add 15, which is my standard deviation, if I add 15, that would get me to a score of 75. So 34% of the scores fall between 60 and 75. Keep adding 15. 47.5% of the data falls between 60 and 90. And keep adding, and then of course we subtract 15, which is our standard deviation. That's one standard deviation, that's subtracting 15 once. Two standard deviation, that's subtracting 15 twice. And three standard deviations is subtracting 15 three times. So we could say that 68% of the data falls between one standard deviation of the mean on either side of the mean. 95% of the data falls between two standard deviations above and two standard deviations below the mean. 99% of the data falls between three standard deviations above and three standard deviations below, which means that 99% of the data falls between 15 and 105. 95% of the data falls between 30 and 90. And I think we may have already mentioned that 68% of the data falls between 45 and 75. So, how much of the data is above 90% or above a 90? 2.5. What percent of the data is above 75? 16% of the data. And of course, 50% of the data would be a 60 or above. And you can skew it off to the right a little bit. Here's, let's see, we could say that 81.5% of the data falls between a 45 and a 90. That's 34 plus 34 plus 13.5. So 81.5% of the data falls between a 45 and a 90. Please make sure you post any questions that you have on Edmodo. And please, please, please call me, text me, email me, Edmodo me if you have any questions. I know you're sitting there doing your schoolwork and I'm watching my niece graduate, but graduation only lasts for an hour or so and it's at noon. So please get in touch if you have any questions.